Welcome to our physics lesson on charge distributions. Today, we'll explore three fundamental concepts that help us understand how electric charges are distributed in different scenarios: linear charge density, surface charge density, and volume charge density. These concepts are crucial for understanding electrostatics in various physical systems, from wires to planes to three-dimensional objects. Let's start with linear charge density. Linear charge density is defined as the amount of charge per unit length. We typically denote it with the Greek letter lambda. Mathematically, the linear charge density lambda is equal to the charge q divided by the length L. The unit of linear charge density is coulombs per meter. This concept is particularly useful when dealing with charged wires or line charges. For example, imagine we have a wire that is 2 meters long and carries a total charge of 6 coulombs. To find the linear charge density, we divide the total charge by the length. Lambda equals 6 coulombs divided by 2 meters equals 3 coulombs per meter. This means that for every meter of the wire, there are 3 coulombs of charge. Next, let's move on to surface charge density. Surface charge density is defined as the amount of charge per unit area. We typically denote it with the Greek letter sigma. Mathematically, the surface charge density sigma is equal to the charge q divided by the area A. The unit of surface charge density is coulombs per square meter. This concept is useful when dealing with charged surfaces or planes. For example, imagine we have a square plate with a side length of 3 meters, carrying a total charge of 27 coulombs. To find the surface charge density, we first calculate the area of the plate. A equals 3 meters times 3 meters equals 9 square meters. Then we divide the total charge by this area. Sigma equals 27 coulombs divided by 9 square meters equals 3 coulombs per square meter. This means that for every square meter of the plate, there are 3 coulombs of charge. Finally, let's discuss volume charge density. Volume charge density is defined as the amount of charge per unit volume. We typically denote it with the Greek letter rho. Mathematically, the volume charge density ρ is equal to the charge q divided by the volume V. The unit of volume charge density is coulombs per cubic meter. This concept is useful when dealing with charged three-dimensional objects. For example, imagine we have a cubic object with a side length of 2 meters, carrying a total charge of 16 coulombs. To find the volume charge density, we first calculate the volume of the cube. V equals 2 meters times 2 meters times 2 meters equals 8 cubic meters. Then we divide the total charge by this volume. Rho equals 16 coulombs divided by 8 cubic meters equals 2 coulombs per cubic meter. This means that for every cubic meter of the object, there are 2 coulombs of charge. Let's compare these three types of charge densities side by side. As we move from linear to surface to volume charge density, we're essentially adding dimensions to our analysis. Linear charge density, lambda, is for one-dimensional objects like wires. Surface charge density, sigma, is for two-dimensional objects like planes. Volume charge density, rho, is for three-dimensional objects like cubes or spheres. These concepts have important applications in electrostatics. Linear charge density helps us analyze electric fields around long charged wires. Surface charge density is used to study phenomena like charging of capacitor plates. Volume charge density helps us understand how charge is distributed in materials like semiconductors. You'll also encounter these concepts when studying Gauss's law, electric flux, and electric potential in more advanced topics. In conclusion, understanding charge distributions is essential in electrostatics. Linear charge density, lambda, measures charge per unit length. Surface charge density, sigma, measures charge per unit area. Volume charge density, rho, measures charge per unit volume. Try practicing with some examples. If a 5-meter wire carries 10 coulombs, what is its linear charge density? If a circular disk of radius 2 centimeters has a charge of 6 microcoulombs, what is its surface charge density? If a spherical volume of radius 3 centimeters has 9 nanocoulombs of charge, what is its volume charge density? Thank you for watching.